In this video, we are going to talk about predicting the direction of reaction. You remember that we're talking about here forward and reverse reaction. Now we know that when an equilibrium is established, the rate of forward reaction is equal to the rate of reverse reaction. That is why, if you can see here in our equation, our equilibrium constant is just simply the ratio of the forward and the reverse rate constants, which are both constant values at a given temperature. Now, say for example, you want to know the direction of the reaction at a particular instance. So, for example, you have this reaction. So the composition of dinitrogen tetroxide to nitrogen dioxide. So at a particular moment, can you predict the rate of the forward or the backward reaction, or can you predict which direction, say for example, forward or reverse reaction is more favored? The answer is yes. We can predict that using the parameter called reaction quotient, which is the resulting value when we substitute reactant and product concentrations into the equilibrium expression. So in order to predict, first is you are going to write the equilibrium expression and then substitute the concentrations of the species at a particular moment to that expression. And then after that, once you have calculated the reaction quotient, compare that to the equilibrium constant. Now, the equilibrium constant is already established. Okay, it is already determined through different experiments. So if the Q, if the value of your reaction quotient is greater than the equilibrium constant, that means that the reaction is not at equilibrium. That the reaction will go to the left as the ratio of products over reactants is too large, and the reaction will move toward equilibrium by forming more reactants. So in other words, if your Q is greater than K, then the backward reaction or reverse reaction is favored. Okay? If Q is less than K, then the reaction will go to the right. So in other words, the forward reaction is favored. That means the ratio of products over reactants is too small, and the reaction will move toward equilibrium by forming more products. Now, if the two quantities are equal, if Q is equal to K, then the mixture is already at equilibrium, so no shift occurs. But again, this doesn't mean that the reaction stops. The reaction still proceeds, but the rate of the forward and the reverse reaction are equal. Okay? So the rates of the forward and reverse reactions are equal when Q is equal to K. Okay, say for example, you have this reaction. So you have B to form 2A. And let us say that the equilibrium constant for this reaction is 2. Suppose you have 3 moles of A and 3 moles of B placed in a 2-liter flask. So in which direction will the reaction proceed to attain equilibrium? Will the concentration of B increase, decrease, or remain the same as the system moves towards equilibrium? Okay, so let us try to solve this problem. Okay, as what I have said, the first thing to do is to write the equilibrium expression. Okay, so for this, the expression is Q is equal to concentration of A raised to the power of 2 over concentration of B. So what is concentration of species A? So as stated here, you have 3 moles of A in a 2-liter flask. So you have 3 moles over 2 liters. So the concentration is 1.5 mole per liter. Then for B, you also have 3 moles in 2 liters. So you have also 1.5 mole per liter. So we have now the concentrations of the two species. So the next thing to do is to substitute the concentrations of your products and reactants to the expression. Okay, so you have Q is equal to concentration of A is okay, 1.5 mole per liter, okay, raised to the power of 2 over 1.5 mole per liter. Okay, so all you have to do is to get the square of this value divided by 1.5 mole per liter, or you can just simply subtract the exponents since the bases are the same. So the answer to that is 1.5, and the unit will be mole per liter. Now, as stated earlier, our equilibrium constant is 2. Okay, so if K equilibrium constant, the equilibrium constant is equal to 2, that means our Q is less than K. So what does this mean? Which direction is favored? Is it the forward or the backward? So as stated here, if Q is less than K, then the reaction will proceed to the right. In other words, the forward reaction is more favored. So if that is the case, then what will happen to the concentration of B if forward reaction is favored? So the concentration of B will decrease as more B are consumed to form more A. Okay, so that's it. Okay, I am going to give you another example. Okay, let me write the example here. Okay, for the reaction for the reaction, 2 moles of sulfur dioxide react with 1 mole of oxygen gas to form 2 moles of sulfur trioxide. And this happens at 827 degrees Celsius. Okay, suppose that the equilibrium constant is 36.9 liter per mole, and you have 0.0500 mole of sulfur dioxide, and you have 0.0300 mole of oxygen gas, and 0.125 mole of sulfur trioxide in a 1 liter flask. Okay. So say for example you mix this in a 1 liter container, like for example a flask, okay, at 827 degrees Celsius. So question, in what direction, okay, will the reaction proceed? Okay, so first we're going to write the expression. So you have Q is equal to concentration of sulfur trioxide raised to the power of 2 over the concentration of sulfur dioxide raised to the power of 2 times the concentration of oxygen gas. Now, okay, take note that all of these substances are placed in a 1 liter container. So that means our divisor is 1. So we can, okay, just simply substitute, okay, since there's no need to divide since the divisor is 1. So the concentration of sulfur trioxide is, for sulfur trioxide, we have 125 thousandths mole per 1 liter. So that is just equal to, okay, mole per liter raised to the power of 2. Then for sulfur dioxide, we have, okay, mole per liter raised to the power of 2 times the concentration of oxygen gas. Okay. Okay. So you can get your calculator and then solve. So what is the answer? So if you are going to use your calculator, the answer to this one is 208.33, and this will be rounded off to three significant figures, because if you are going to look at the given quantities, the least number of significant figures is 3. So the final answer must be rounded off to three significant figures, and that is 208. And what will be the unit? The unit is liter per mole. Why? Because as you can see here, you have mole per liter raised to the power of 2, and you also have here mole per liter raised to the power of 2. So this is cancelled. What is left is mole per liter. So this becomes 1 over mole per liter, and then get the reciprocal of this, and the reciprocal is liter per mole. Okay, so compare now the values of Q and K. So as stated in the problem, the equilibrium constant is 36.9 liter per mole, which means that our Q is greater than our equilibrium constant. So if that is the case, then in what direction will the reaction proceed? So as stated here, if Q, where is it? If Q is greater than K, the reaction will go to the left. What does this mean? That the reverse reaction is favored. That means the ratio of products over reactants is too large, and the reaction will move toward equilibrium by forming more reactants. So if you are going to compare the rates of the forward and reverse reaction, then we can say that the rate of the reverse reaction is greater compared to the rate of the forward reaction. So that is why reverse reaction is favored. Okay, so our next video will be about calculating equilibrium concentrations. Okay, so please wait for that video.